Hey everyone! Thank you so much for watching another episode of the Weaviate podcast. I'm super excited for this conversation, diving into the Vertex AI RAG engine. This is making it easier than ever to build RAG, agents, compound AI systems with Google Cloud, Vertex, and Weaviate. Firstly, I'm super excited to welcome Weaviate co-founder Bob Van Light. Bob, thank you so much for joining the podcast.
Woo, thank you.
Awesome. And I'm also super excited to welcome Louis Liu, a product manager at Google Cloud. Louis, thank you so much for joining the podcast.
Hi, everybody. Love to be here.
So, what kind of ship is that in your background, Louis? Let's get the important stuff out of the door. What is it? Is it like a pirate ship?
Yep, there's a pirate ship, the Lego one. I think I got it as a gift from my mother, probably around 12 years old. I have been keeping it. Yeah, really love it.
Yeah. I was so curious when I saw it. But thank you for joining. And oh man, I mean, I think Connor, you also you noticed, of course, too, the excitement we saw today at Weaviate when we saw the beautiful release of the integration. That was fantastic, because anything we can do to help developers make it easier to build RAG is something we jump on. So this was really fantastic. So thanks for that.
Yeah, it's great. I mean, we have been talking to a lot of customers, developers. I think one of the things they often ask is configurability, right? We use VBA, we use some of the open source stuff, right? Can we leverage the same thing without changing too much of the code, right, on Vertex, on Google Cloud, so they can scale it? Yep,
Yeah.
I'm super excited about this integration.
There's something that I'm super curious about. So I'm not sure if you can share something here, but since I mean, since as far as my memory goes back, Google is of course famous for the development rigor, right? So how software is developed and how well that's done, and that's of course it's famous for that. However, that also takes time, right? So just to build high quality software. Then you have all this AI craze that's happening, and so you wanna also, of course, be part of that, especially when you're Google, of course. How for you working at Google? Because we're a startup, right? We're crazy all the time, right? So that's that's our default mode. But the what is the did was did you see this as like a just another product, or did you say no, the fact that it's now working, the Gemini models that's in the AI space really gave different kind of sense of urgency or feel to it? Or were you like, nah, it's just not a product?
We actually feel some urgency about this, right? So the team actually started this journey, as you said, developing great software takes time, right? The team started actually early in 2024, and then we go through a couple of iterations to really polish the product and making sure it meet the developer needs. One of the thing, as I said earlier, is to like the lesson learned, right? Is to meet where developers are, and many of them actually use open source stuff where the whole ecosystem is moving at lightning speed, right? At this point, right?
Yes.
We really want to focus on things that my team, or Google have expertise on, right? For example, how we scale this pipelines, how can we run this really quickly, but rather than building another vector database in my team, right? So that's sort of the reason that we say, hey, let's focus on getting these pipelines in a very scalable way, right? And then being able to give developers choices on different systems they can use.
Yeah. That's interesting, because it was so funny, because I was going through the something as simple as the notebooks, right? It's so well documented and well structured. It's just that's always a joy to go through and to read and to see these kind of things. But I could also imagine that actually, but I don't know, actually, uh, is your background in the engineering or on the ML side? That's actually something I don't know.
It's actually engineering. Yeah, I was
Ah,
an engineer for working on the cloud infrastructure for a couple of years. And when I moved to Google, I started doing a lot of AI ML stuff. specialized in the NLP space. I think Bob, we talked a little bit on the knowledge graph, right? Like
Yeah,
I
yeah,
worked on a couple of products before start doing the large language models.
yeah. Oh, then I have like a question. So a hot take. So in the early days when I started to work with these embeddings, so for me, there was 10 years ago with Glove. That was my point of entry. And so we didn't talk. We were not talking. The word AI wasn't really used, or the abbreviation, and we were just talking about machine learning and these single word embeddings and those kind of things. And people were not, let alone stuff like RAG, etc. That was just not talked about. And I recently found a presentation from 2016 I think I posted it somewhere on social media, where I thought that the use case for these embeddings was knowledge graphs. And what specifically in the knowledge graphs, I was thinking about entity recognition, right? So the
Yeah.
moment that you were able to identify an entity, then you could just traverse the graph. But the challenge was in identifying it. But now there's even on the Google Cloud YouTube channel, there's an interview with me from 5 years ago where I literally talk knowledge graphs with Weaviate. But I've actually changed my mind. I think what we're doing now with the vector database and what we can do with the embeddings and the generative models, we can kind of leapfrog over that, because do we really, I mean, of course use case will always exist, but on a larger scale, do we really need the strict relations in entities anymore with these new technologies? And I feel that we don't. But I'm curious what you think, if you agree with that, or if you're like, you're nuts.
Yeah. I think I actually totally agree. By the way, I watched that YouTube video back like you had it a long time ago. My view also kind of evolved as I see how powerful these models are these days. Because initially I thought, oh, having a really strict ontology is awesome, right? Like, you have a schema, like there's no ambiguations about definitions, right? You're always going to go to the source of the truth. Um, but it's super complicated to build, right? Like Google take years to build a knowledge graph, and then we still refining our ontologies internally, like on daily basis. um, I don't see, other company actually can invest and do the same thing. With the LLMs, these models are so powerful that it can actually understand the relationship and these data, and even in the graph format, right? So that's where my thinking is, yeah, I mean, we probably still want to have the graph representation of the data, right? But it not necessarily need to be like strictly enforced by a schema. And then the model should be able to digest or use different tags, right, to be able to pull the data to do the data retrieval and still traverse the graph somehow, right? But then the way we traverse the graph might be total revolutionized, using LLM rather than the traditional way.
Yeah, because I'm thinking, what's so interesting about, and I'm not sure if you agree with this. What's so interesting about knowledge graphs is how well it's organized and structured. I love that. I love it. It's like, I
It's
love it when
engineering
stuff.
marvel, right?
Yes, exactly. So, but I still remember, I had this insight. This was just before COVID. I was invited. There was also a relation to Google, because it was back then I was in this community of developer experts, and I was invited in somewhere in Greece,
Hmm.
and I was talking about embeddings and entity resolution, that kind of stuff. That was all very primitive, but I was presenting it. And at some point, this person raised his hand, and he goes like, he said, "You know what?" He said, "I work for the European Union." He said, and he said, "What every country in the world calls a lake, the Germans call that a sea." And I just cannot fit it into a knowledge graph. I said, nobody agrees with how I try to come up with my ontology. And I had this insight that I was like, the problem is not the technology, it's the people, right? That we just don't agree on how to, on formal definitions. And then I was like, maybe then that is resolved with the um, with the models. And but one thing that I'm surprised about that we haven't seen more is actually the vectorizing the relations in the graph, right? That we basically just have an embedding where the modality is the graph, right? So not language embedding or whatever you, but a just the graph vectorized, and then we'll probably lose some information, but we can still, I think we still can do shortest paths based on distances in these embeddings. So I would not be surprised if we see an innovation there that we just say like from now we're gonna do graph traversal in vector space.
Yeah, yeah, yeah. I agree with that.
Yeah, great. So now then we're done. No.
Yeah, I think it's a very natural kind of evolving space that people want to get into, in my opinion, because um, people are trying to explore, for example, these traditional embeddings like LLMs. Like I don't know, like we're pushing that to a certain limit, right? And people are start to explore new spaces, and then I think a graph is a really really great place for people to do more research and stuff.
Yeah, exactly. Yeah, how do you see? I'm actually curious. I don't know because you, of course, Connor, you are 1,000 times more knowledgeable than I am about all this. What is? How do you look at this?
You put me on the spot too much with that, but I haven't thought about like vectorized graph traversal too much yet. I mean, I really like it's super interesting idea. I think the multi-vector idea is kind of like that, where because you have more than one vector per object, you're kind of like have multiple edges in that sense, I think. But something I really want to ask you about, on this topic of ontologies, and Lewis, this also comes to the RAG engine and kind of the underlying data model is I'm really curious about like data warehousing where you have multiple tables, multiple collections, and so I'm really curious like where you draw the line between like the schemas you'd manage in a warehouse. Like I have my marketing analytics, I have my blog posts, I have maybe like my some other kind of table, and I'm trying to organize all this, and I'm curious like when is this an ontology, and then I'm just curious about like the RAG engine, like RAG engine is kind of assuming this data model of like a document search index, correct? And so I'm just kind of curious like how you both are seeing like the data model behind these kind of things, and yeah.
Yeah, you want to go first, Louis?
Yeah,
Yeah.
I can go first. I think I mentioned this a little bit earlier. I think initially I like when I worked on the knowledge graph projects. Like, okay, let's get a universal schema, right? The thing we have been really pushing is we have schema to work that's more tailored for consumer type of ontology. Like, can Google, like we worked on an enterprise version of that, right? We can expand it more than just crawling website, right? We can cover a lot more use cases. It's extremely hard to implement. And again, when you get these into customers and developers, it's like, oh, like I want to call this lake, not call it as a sea, right? Like all these problems coming, and then particularly, Connor talked about like when I have different definition of the sources, like you cannot go into the sources and say, hey, go and change those definition. So in the context of RAG, I really feels like when we start doing these type of kind of multi-sources stuff, you need a reasoning step like agentic flow in the middle. Somehow, LLM can help you map it automatically, right? And understand the context. It can know, okay, here you mean C, and then there I should translate it to lake automatically, right?
Yeah. And that's for me that that the story they always tell around that is the like many years ago when I was running my tiny software consultancy company. I was hired by a large enterprise, and that was the time of everything became like RESTful, right? RESTful APIs. So I'm dating myself a little bit with this, but the that was the big thing. And and my consultancy company, we were hired to work on something related to that. And I was very ambitious, and I was like, we're gonna this whole large enterprise. We're just gonna these RESTful APIs. They return all these objects, and we're gonna just unify that into one. And the person who hired me back then said like, that's not possible. And I thought, no, he's just old fashioned. He thinks the old way. And he gave me an assignment that I'll never forget. He said, I'm going to introduce you to 3 people in the business. You're going to talk to these 3 people. And when you're done, you define a JSON object um, uh, um, that represents a customer for this company. So I just talked to these 3 people. So I talked to the first person, and I like, this is super easy. So I just draft like one, like JSON. So I go to the second person. This person goes, well, I don't fully agree with this because, when we say customer here at the company, we actually mean, well, yada, yada. Now, when I went to the third person, I could just throw it out of the window because, long story short, I couldn't come up with one formal definition of customer for this one company. And then the lake and the sea example is a good one that you mentioned, because what's so beautiful with the models is that you, in your prompt, you can basically say, well, it's always a lake, but bear in mind, if it's somewhere in Germany, then they might refer to it as a sea. And then the model helps you to navigate through that. And it just, that the data is ambiguous just doesn't matter anymore. If you just prompt properly, it just helps you to navigate that. And then the next step is, so then why do we need those formal relations? If we just, do we still need them? And that is really where I changed my mind. That I hope that there are no semantic web fanatics are listening to this, but I'm not sure if we still need them with everything that has now happened.
But you actually brought up a great point. I think I want to challenge, like we said this, like we both said this, right? The like let's just say German gonna call, I forgot, like lake, sea, lake, right? These
Yeah.
kind of a knowledge, and let's say in the LLM world, in the RAG world, the LLM itself may not really understand this in that context, right? Like somehow developer might be typing something into the prompt as a very rigid knowledge to say, keep in mind, if you're talking about in Germany, like in German, then you should do this translation. I can see this type of rules going to just accumulate, right? And then that really just feels like we are going back to the old world, right? Like what really matters.
I love that you say this, because this makes me think about something else. I don't agree with the people who say stuff like, because of prompt engineering, software engineering will go away. And the reason that I don't agree with that statement is super related to what you just said, Louis. Because the example that I always is this. So if we take a model, right, generative model. So if I now go to Gemini and I say, render an HTML page with a red circle in the middle, it will do that. It will give me HTML with CSS with a red circle in the middle. But maybe I don't like how the size of the circle. So now I prompt it again. I say, make it bigger. So it makes it bigger. I say, no, not that big, like less big. So I somehow need to start to introduce some formality in my language.
Yep.
To tell the model, no, make it 1 pixel bigger. And then before you know it, that I can really prompt the model to do exactly what I want it to do, I'm typing a formal language, i.e. a programming language. So we might see something new in like a new type of programming language, but in the end, the formality in the language, we need it to properly prompt it, because otherwise we're too vague and too ambiguous, and it does what we ask it to do, but it can't be precise enough to do it. So it's definitely going to lower the barrier to entry for people to write software, which in my opinion is fantastic. The more people can write software, the better. But we will always be stuck, I think, or if we stay with the status quo now, we will always be stuck with some formality to somehow, because what we want, of course, with the software is that if I let's say that there's a new version of Gemini and I give it the exact same prompt, I wanted to generate the exact same HTML page with the exact same
Mhm.
red circle in the middle, right? And I don't want to have any ambiguity there. So that's that's why I think that the languages will never go away, but the formal relations between them might.
Hmm. That's an
That's,
interesting
that's
point. Yeah, I mean, I think both of you might have seen there's the Menlo Venture kind of reports on AI, right? And then basically talk about how prompt engineering is actually decreasing, right? I think to your point, at one point we're gonna say, hey, this is gonna replace everything, people just prompting, but then in reality, and I thought there's another interesting trend, right? Like the number of people doing prompt engineering is decreasing, the number of people doing fine tuning on these models is also decreasing, right? I think,
yep.
and then the only thing you see people is going up is RAG, right? Retrieval
Yeah.
augmented generation is like it's kind of the number one right now in terms of the techniques people are using today.
Yeah, but this is something I find fascinating in technology, that there's this so because of course I am in my role at the company, I'm shifting between different hats, right? So some might be like sometimes a tech hat, product hat, or business hat, and those kind of things. So if I put on my business hat for a second, I am fascinated by the concept of good enough. And so the fine tuning is a good example of that, right? So the fine tuning was, if you look at it from a business perspective, not a tech perspective, a business perspective, the fine tuning was only relevant as long as the general model was not good enough, wherever the threshold of good enough lies, right? And so when these models became bigger and better, and with it was very logical for me to see fine tuning going down, and the fact that RAG went up is something I also found logical, because the the moment that these generative models went mainstream, the question that I got the most was, how do we do this stuff with our own data?
Mm-hmm.
And people, do we need to find? How do we do that? Do we? And I was like, yeah, there's an easier way of doing it. So it's kind of this. I mean, look at the notebooks that are now released, right? So on the Vertex website, it's this very easy. It's like I think you run through the whole notebook in, what is it, 10 minutes or so, maybe less. That's the state of where we are now, and that is how people build and do things. So it makes sense to me that that's the trend that we see going up and going down. The same thing is that when I started in the company, there was this question floating around: will software engineers become data scientists, or do data scientists will they become software engineers? So will the data scientists learn more software engineering, or will the software engineers learn more data science?
Hmm.
Right? And I was super biased because I came from an engineering background, but I was like, no, the engineers are going to learn just more about data science, and then just incorporate that into their work and build. And I'm happy to kind of see that. I think I hope I'm not making somebody angry listening to this, but I think that that's kind of what we see, right? It's a more the engineering spirit hasn't changed. Right? I'm curious for you also, so Louis, as an engineer, do you use generative models to write code now, or do you still do it the traditional way?
I think a lot of so I'm not an engineer anymore, so
Oh.
yeah, I mean, but across Google, right? Like the internal tools actually use a lot of generation, like Gen AI stuff, right? Auto completions, right? And then you can write some comments and help you generate code. I mean, just as a product manager, we use Gen AI all the time, right? Like paraphrasing things, polish a template, polish like email, and it's very common. But I think your point on good enough is very interesting because at the beginning of the podcast we talk about like engineering model, right? Like engineers are really kind of great at solving those challenging problems. Like one thing I see with tuning is a lot of with these models getting so powerful, a lot of people can get to 90%, 95%, right? Just with prompting. And when they start deploying these in production, they say, oh, like look at my prompt. I got like 3,000 token, 5,000 token, just writing this, and I have to repeat it all the time. It's costly, right? And then people say, okay, let's try to fine tune it, and I can get these things burned into the model. Like I don't pay for those tokens, right? I still see these are common use cases, but then it really just depends on where those developers or the production stage is at, right? Like if they're just prototyping, absolutely no tuning. But then when they get into production, like tuning and some other approaches like distillation, right, for RAG, I think is super important to get the
Yeah.
cost down.
Well, I think something that's really interesting about this is like, like a big joke is like graduate student descent, because it's all about like the professors. They kind of know like some configuration of these hyperparameters will solve this problem, but we just need to, test it. And what about this like LLM as optimizer, or, because like a lot of data scientists is like you're looking through the results of these configurations. I think this kind of like LLM as optimizer is so underrated, and I'm like a DSPy advocate all the time on this, especially when I'm talking to Pablo. But like this like LLMs optimizing things, I think, yeah. I'm curious, like if what you think about that kind of like just using like LLMs to do this meta optimization, whether it's like to monitor a distillation process like you mentioned, or just any kind of tuning, like with RAG, like with the Vertex RAG engine, you have like these different chunking strategies. You have these different like, embedding, blah, 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 like which model to choose. And you could use an LLM to kind of tune the optimal configuration of the RAG engine. Does that kind of thing interest you?
Yeah, absolutely. I think right now the focus of the RAG engine is to get people start really quickly, right? And then help them to get to like 90, 95% quality. So they can actually start thinking about how I'm gonna really move this into production, where a lot of more engineering magic gonna come, right? Like how can I do the tuning, distillation? Can I actually use LM to figure out the best parameter, right? I do a bunch of experiment. I think the pipeline is super important, because when we work with one large customer that they actually trying to build a rack system in house, they have millions of those manuals, like product manuals, and they say, okay, let's try this config, and it just like literally take them like a week to get everything, go through embedding, right, run this pipeline, and then do some eval. It's like, oh shoot, I should tweak this number from like 0.5 to 0.6. Let's repeat this, right? Like we don't even have a really good scalable pipeline today. I think with RAG Engine, we really want to just unlock this so people can really quickly testing different combinations. And according to your point, I think this is kind of a world where we want to be like AutoML. Like I'm not sure if you know the AutoML kind of
Yeah.
saying is like you use machine learning to figure out the model architecture. Here I think it's the same concept, right? Can we use LLM to help you figure out the configuration based on your corpus, and then we just try them out, right? And then we probably kick off 10, and we say, hey, this is the best configuration for you, right? We don't have that today, but I'm pretty sure a lot of people are actually moving that direction.
Interesting. So
Because
I've
these things are
yeah.
really depends on you have a super scalable, highly scalable infrastructure, right? And I think this is where, like at least from Google's standpoint, like this is where we're really good at.
What is the so I mean, of course, we see a lot of this from the Weaviate perspective as well, but I'm curious from your perspective, because you've been looking at the whole pipeline basically. In your opinion, what's the biggest bottleneck right now, and the lowest hanging fruit to just solve in this case in Vertex?
Yeah, I have my view. Love to just do the check with you, see if you see the same thing. I think right now the biggest bottleneck or the opportunity is still somehow at the parsing stage, right? I think the people are actually trying doing different things. Um, doing a summarization of the documents, chunking the documents, and parsing the table out, doing very special thing about different elements of the documents, right? I think this whole space is could get very deep, or you could just ask LLM to say, do 10 different tasks for me, but then getting the data in certain way that the RAG system can use it. I don't think this is well defined. I think this is a space quickly evolving. I also see a lot of people trying to invest a lot in this step. And this is also the step that can increase the overall quality a lot, right? Like, you tweak some of the re-ranking stuff, and then yes, it helps. But I think so far, from my experience, the biggest thing is still like the parsing stage.
Mm.
Is that what
Yeah,
you're seeing, or?
yeah. So for me, yes, absolutely. But I'm also interested in things we currently do where we have inference over a model, be it an embedding model or generative model, where we don't have to do inference. So a very simple example of that is reindexing, right? So the example that you just mentioned, if you have I don't know 100 million documents, and they're like, oh, we're going to change the embedding models, then you just have to do 100 million, times you have to, call the model again. And things that I'm excited about is that, for example, that you could say, well, we take a sample size, so we re-index 20%, and based on the old and the new positions of the documents, we try to say something out of the remaining 80% without doing inference. Those kind of things, right? I'm also the um, when I did some digging in a Transformers library, because it's open source, so it's easy to do. It's the amount of the number of times that we generate embeddings to do something, be it for the tokens, be it when softmax is applied, all those kind of things. The pure memory bound KV cache and those kind of things, it feels that we can optimize it a lot there too. And that, forgive me for sounding a little bit abstract there, but I do think that there's a lot of stuff there under the hood where we can do a lot of optimization, where it's not per se, oh, we just want to do faster inference and then we just solve it with only faster inference. Because I just if you run something like the Flash models or something with Olama just on your laptop, you can just see if this would work faster, this would be just the ideal scenario. That I don't have to buy an expensive piece of hardware or rent an expensive piece of hardware to do that. So somewhere there, I think there's also room for. So what you said, Luz, is by far lowest hanging fruit, most straightforward one that everybody talks about. But the other thing that I'm also thinking about is more that kind of optimization. So, but I'm not sure what you think, Connor. Actually, to be honest.
Um, yeah, well, I know that Bob, you have all sorts of thoughts on the key value cache, and I get, so, but I mean, maybe I kind of, I guess I did want to just ask this question about. So this is a question for Bob, sort of, as well as this broad topic around tuning RAG pipelines. So Bob, sometimes when I hear you talk about generative feedback loops, it sounds like you're talking about you want this high level agent thing where you give it a command like, "Hey, I want to test this other embedding model," and then just you figure out the entire thing, like the generative feedback loop API. You go figure out the entire strategy for how we're going to do this, and or if you have some kind of pipeline where like you have a subset and then you kind of have like this LLM monitoring the tuning thing, so it's like some kind of pre-computed thing versus like this totally open-ended. And kind of thinking about this put me in this like declarative programming languages type of topic. And so yeah, I guess I'd love to. I know the key value cache is an awesome topic, but I just if you let me get this question in of like when you're talking about kind of LLMs controlling the databases, is it like do you mostly envision it in like you just give it any kind of command like, hey, I want to test this other embedding model? Yeah.
Yeah. So it's the so for Also for the listeners and for Lewis, if in case that you're not familiar with the language, but so we refer to it as generative feedback loops because we've seen that RAG that's like a one-way street, right? So if the query, factorize it, retrieve, go to generative model, and you present the results. So it's one directional. Great, lots of value. Uh, but the idea is very simple. What if you use that to just feedback loop that back into the beginning, right? So rather than querying, basically storing or updating or deleting, what have you. And then when you edit an agentic, that is a agentic architecture where we just create a feedback loop. And then you can make them bigger and as complex as you want. So you could, for example, and I make this up on the spot, but based on what you said, Connor, you could have two different models that debate with each other if something is well done or not well. So I sometimes do that. So it's I literally had this the other day. I wanted to do I needed a regex for I was doing some data analysis and I was like, I'm gonna prompt two models just to see what they give me back. And they gave two different solutions, both worked, but I don't know. I'm not good enough at regular expressions to actually know which one was like better. So it would be fun. So what I did is I copied the response from one into one and then into the other. I said like, is this one better? And then one model said, yeah, actually this one is better. And the other one said, no, it's not better. So now I could imagine that something in a RAG pipeline from the database presented to not one model, but to two, where it's just like, what do you think of this? Is this correct? I say, yeah, I think it's correct. And we ask like second opinion from another model, and then we feedback loop that back to the database. That might be an example, or what you just mentioned, Connor, in that we generate but basically anything that we want based on the data. But the power sits in the fact that the problem that we're solving is that the power in the vector database with the generative model is that the generative model is stateless. That's the problem we're solving here. So we're giving it real-time information that might even be piped into the database and vectorized real-time. And that in harmony, I really think that just RAG is the first step because it's one directional. And what we do with the agents is that we make it bi-directional or we feedback loop it or those kind of things. So I'm not sure if this is an exact answer to your question, but those more elaborate architectures, that's something I did. I'm pretty certain that this year will be the year where we see more of those elaborate architectures because I just noticed it from the questions that people ask me about how they're building. But I'm not sure. I'm also curious, Lewis, if you see those kind of trends that these architectures are starting to become more, sophisticated, if you will.
Yeah, absolutely. I think agentic stuff are getting a lot more popular. I think there are also a lot of use cases actually require a certain level of reasoning. Right? You have multiple corpus, like which one you should really use. Are you just sending it to every single corpus, or you're selective and then picking just the one that are relevant? But like the point you're actually making is a very interesting one, Bob. Like, are you like in your mind, right? Like typically when we say this feedback loop, it's kind of user give you a sum up, sum down when they do the side by side. But here, I think you're more talking about like GAN network, similar to that, right? Like you just have model that gonna be competing each other, and then like it's automatic loop. You have another model say, hey, this one's better, and then you just let the model to kind of evolve itself, right? And then
Yes.
eventually there can be one winner or something.
Yes, and I by the way, I love that you mentioned the GAN network because it's that's literally what it does. But the the idea was born from the fact that I this and it's a couple of years old that I there's a somebody I know is a CTO at a large company which and they have many factories all over the world. And the problem that they have is they have all these master data management standards. But the problem is all these different implementations over these hundreds of factories all over the world, they don't exactly follow the standards. right? And that it's nitty gritty, it's small stuff. It's like the data standard might say everything needs to be stored in American English, but the factories in the UK, they might write stuff, in British English. It might be how temperatures are recorded in Fahrenheit or Celsius, and there's always a mistake somewhere. There's always a human error in there, and that data's coming in like en masse. But the interesting thing is, and he told me this many years ago. He said, if my peers on C level from business side ask me a question, like how many XYZ did we produce or that kind of, he said, I can't give them an answer. I can run the query, but I know that the answer that comes out is actually factually incorrect because of these master data management issues. And so I asked him, how is that solved? So that's just an army of people going through the data, trying to fix it, who in turn also, they are slow, relatively speaking, of course, and there's human error involved there as well. So it's like a perpetual problem that just the data comes in faster than it can be fixed. And that was where the idea was born. It's like, well, if we can do RAG to get it out, why not ask one or two generative models? Is this in line with our master data management policies? If no, what's wrong with it? And then store that back into the database, or fix it, or update it, or however we want to do that. And out of that, the idea was born, where we want to go, and that's what we now doing with Weaviate with the generative feedback loops, is that we want to say, why not just prompt the database directly, right? So yes, it's still the model, but if you, for example, create a collection or data object in the database, you give it a prompt, an instruction, and you tell it what the database. So you can say, like, if it's not adhering to your instructions, reject it, or just store it and give a warning, or store it and store a second data object that is the fixed version, and that kind of stuff. So you're basically giving the models an opinion based on the instructions on the data, and then the big idea around this is like, can we use these agentic architectures to solve the master data management problem
Yeah,
that
that's basically
any
the
company has?
data steward, right, type of job, right? Like, are these the same thing? Can I like merge them, or should it one replace the other? Yeah.
Yeah, but this nicely ties back to our conversation earlier about the knowledge graphs, because the problem is we were only using formal language. So let's now not think knowledge graph, but just think a data store, SQL language. So a human needs to go into that data set, come to a conclusion about the biggest issues in the data set, needs to define a SQL query, basically select and an update to solve what he or she has uncovered. And that's just a perpetual problem, because there's always something else. The SQL language is too formal, like the knowledge graph, to capture everything. And now taking this completely different path, where you say, we just pipe everything to the model, and we just tell it, if there's something wrong with this, fix it, right? And I think that what we like to refer to this as like an AI native way of doing stuff. So it's really at the heart of what we're doing. I really think for data management in the data store, I really think that's where we're going. And that's what we're doing with the generative feedback loops as an agentic architecture and those kind of things. And making that into form of a GAN network, where we basically say, like, hey, we have one that generates it and I want to checks it before it goes back. Sure, why not?
Yeah, I think if we're cutting a clip to send to Andy Pavlo, or maybe saying that we think the SQL thing, I think the whole thing is that it's declarative on top, but we think natural language is like, if declarative is the thing.
Yeah. I think he's gonna kill me when he hears that. But no, the thing here is what I find so exciting. I was by coincidence, did another actually podcast today, and we talked about this, where I said, what's so exciting about this time right now is that we can completely we can lean into the paradigm shift of how we make software and how we make platforms, products, whatever you're building, tooling that's like different from how been doing it in the past. And look, if I look at just the Weaviate users and our customer base, that is still a lot adopting AI, but in the previous paradigm. But it's especially the startups that I see that are really going the new way of building software and building applications and coming up with new solutions and products that you just simply can't do in the previous paradigm, how well you've structured something or not. And that is why I think we also as a company really need to lean into this and say like we help you to build these new types of applications and solutions. But that's just how I look at it. So, and there's so much more work that we can put into these agentic architectures. You're probably going to see that, Lewis, with Vertex, where you're going to see like hey, actually I tried to do this, or like to try to chain that to each other, but I can't. And then there's like we just seen the beginning of it. So it's like that's why I'm so excited about it.
Yeah, totally. I think I think everybody knows this, right? Like when Gen AI comes, everybody say, "Hey, it will completely revolutionize. Like it will replace, like it would do all automations, right? Like no human for anything." But I think we are kind of 2.5 years in this. Probably majority of the use cases do like chatbots. How like I saw a lot of enterprises doing this with batch, right? Like have a lot of data. Can I just go and tag all of them for search, for translation, for all type of use cases? But really, for these kind of master data management, like these data problem, we really haven't seen a disruptor or somebody to come in to solve it, right? Yeah, I think there's a great potential. A lot of things is also anchored to what we just discussed. Like when there is a company kind of a master data schema or ontology, also like I have a friends like working in these automation spaces where you just look at the menus that they've written for human and say model go and follow that, but model can only perform probably 70% of the job because there's still so much thing that embedded in people's head, right? Like these are experience, there's like they scan through, you know, 1,000 entities, 10,000 entities, so that they know there's something that is not on the menu. I think with the RAG architecture to kind of fashion those knowledge, or just having like the large language model have a longer context window, right? To really just look at the whole picture to understand what's happening, things that are outside of like a manual, right? I think that can really help.
Yeah, that's a fascinating point, and that makes me think of a years ago. I went to a conference it was in Iceland, in Reykjavik, and the conference was called Material. I don't know if it still exists, but it was before COVID. And the people who started the conference, it was four people working in technology, software, and those kind of things, to learn how it is to work in the physical world. So the presenters on stage were people like, who were building like there was one, I believe, like a sheep herd or something, like, so we had to like feel the wool and smell it and that kind of stuff. And the reason that they organized that, because the opening was that they said technology is evolving so fast and a lot of information gets lost. And they showed a drawing of a big crossbow that Da Vinci designed, and it's the design. It has all the instructions on how to build it, but they said we can't do it anymore because Da Vinci has assumptions about how we need to work with the wood and the materials. That is just lost information. We don't know how to do it. We can't build the thing. And the question they asked with this is like, what can we as technologists learn from people who work in the physical world in industries that are hundreds of years old, or maybe sometimes even thousands, where all that tribal knowledge stays within that domain, right? So, and whereas it in technology, it's one framework after the other, and people build knowledge in that, and then it's the new thing, and so we lose that knowledge. So all these things what you just said, Lewis, about how when we read the information or we write the information down, even if you make a master data management policy within an organization for how you want to store your data, has so many assumptions in it, what you know about the products or whatever you're storing in that data store, that the model just doesn't know. It was never presented with that information, and so it will never get to 100% because it needs human help to know what it's looking at. But if you get to 70%, that is such a huge win in the challenge that master data management is today. Is that I think it's definitely worth it.
Yep.
Does that make sense? I hope that makes sense. If I see Connor nodding, I'm like, that's probably something.
That's amazing. I guess it's like we think, like in the Vertex AI RAG Engine blog post and that visual, we think so many of those steps can have more LLM, like the parsing part, I'd say particularly where you're, chunking. You could do that Anthropic contextual retrieval thing where you add context to the chunk with kind of LLM back to the database, or it's like which collection do we store this in? That's kind of like LLM. Where do we? And so I love this topic. But so one kind of question I did have from the podcast, from the announcement blog post, Lewis, and I've kind of been on an enterprise software kick. Our last podcast was with Morningstar, and kind of it took me a bit to understand this Morningstar intelligence engine, kind of similar to the RAG engine. It's not like itself a chatbot. It's kind of like something that you plug in other software to, and this whole like future of software. So my question is, in the blog post, you go right to, hey, you can use RAG engine as a tool for a Gemini agent. And so I really would love to just learn more about how you see that kind of software where it's like agent as a tool for some other agent you might be building. I thought it was so interesting to read that.
Yeah, I think factuality, or just in general, we call this grounding. It's highly critical, right, for enterprise adoption. I think on one hand, we want these models to be creative for some type of use cases, right? But then for RAG, for enterprises, we want the model to be conservative, right? The model gonna not rely on something that is embedded in knowledge, could be outdated, right? We just want that capability of doing reasoning, right? And the driver for that basically is when we looking at how to build the next generation of Gemini, we'll want to teach Gemini to use tools natively, right? I think we recently launched the Google search, which actually we teach the Gemini to realize what is own limitation about getting information, right? So these are the information you can answer. These are the information you cannot. You have to rely on external data sources, right? Where we see with RAG in general, like we also want to get to a place where the model going to understand I'm reaching my own limit, right? I have to rely on something externally, and then that externally thing today we kind of use Google search to use that to be that knowledge base. But in the enterprise world, we want the model to realize, okay, I have to rely on my sales data kind of corpus or index. Oh, now you're asking something maybe for a HR department, so I should be able to talk to that. I shouldn't rely on anything internally, right? So these things right now, it's more rigid today. Like you have to really prompt it, or you have to have a reasoning loop, right, to handcraft it. But hopefully, in the near future, we can let the model to realize these type of thing, and then being able to just make those automatic judgment. But again, the challenge here is because like in the Google search world, we actually know what are world knowledge, right? So we can train it, but we don't know each enterprise's own knowledge. So it's really hard for us to say, okay, this type of information, you should go to this database or whatever. So that's where I think Bob's kind of concept about have the reinforcement loop, have the feedback loop is pretty important, right? Like these things sort of have to be going out with some sort of capability, but have to go through a tuning or feedback loop in order to really tune for that type of cases, right? But then our goal or vision about actually building that as a tool is because we think the RAG, the kind of a memory thing of the model is is going to be like the future is going to be something the model have to natively be able to do that.
So I have a question about that. So the so let's say that you use this internally at Google, just for sake of argument, right? And you say, what was, I don't know, you want to have some sales insight. So you say like, what was Alphabet's revenue in the last quarter of 2023? Now you have an interesting problem because Alphabet is a public company. So somewhere in the training data where the model was trained on, Q3 2020 Q4 2023 somewhere sits in the model, but you now need to tell the model, no, we have an enterprise use case, so we want you to not find this based on what you're trained on, but the internal data that we have. Can you share a little bit of how you go about that, how you make sure that if the model for lack of a better term, if the model thinks that it knows the answer, that you still want it to go through like a trusted source?
Yeah. So I think the naive way to explain this, I don't think this is exactly how it got implemented, is kind of, let's just say, through a system instruction. Right? You can actually just train the model to have, let's say, do not rely on your own data, but then you ask the question, right? And then you give the model kind of a positive feedback loop. Yes, you can. Sorry, did I say the other way around? Like, you don't have this sentence, you ask a question, the model answer it, rely on its internal knowledge, that's fine, right? You say this is okay. But then you train the model with a different variation where in the system instruction, you say, hey, you cannot do that. You have to only look at the context within the prompt, right? Or you have to basically yell that, hey, this information sounds like external kind of information, right? And then we train these models based on those instructions, and then the model going to behave that way, right? And then in that kind of path, we have to do some additional work to basically figure out, okay, is internal knowledge, or it should be Google search or some other data sources, right? And then this is I think a very challenging part at this point, to how to expand this from something we know to like universally everybody can use.
Yeah, fantastic. It's so, this stuff is so exciting. I could keep going for 2 more hours. We won't do that to you, Louis, but if I had to, I could.
Yeah, I think one of the things I really like about the RAG engine is you can really start it in seconds, right? I think we can talk about for
Yeah.
hours, but then people can already probably build a super great RAG architectures, given the same
They
amount
could
of.
have been done and have it implemented while listening to this podcast.
Yeah, or they should probably just do that. Like, okay,
Yeah.
we just do a RAG as we all talk about this.
Yeah. That's actually a good idea.
Yeah.
Nice. Thank you.
Awesome. Well, Louis, thank you so much for joining the podcast. Bob, again, this whole Vertex AI RAG engine, it's been such an amazing announcement. The whole thing's so exciting, and the conversation just shows how much love we can keep building, and it's all so awesome. Thank you so much.
Thank you for having me here. I'm very excited, and then let's build more partnership.
100%. Thank you so much. It's fantastic.